But at the same time, it kind of brings a wondrous realization. And that realization is, about our true nature, that we're actually very special, and we start to realize that there is a purpose to our life, and we are beginning to understand more about ourselves and about this place that we inhabit. Okay, so it's kind of like the first day of school, all over again. But this time, we are quite engaged, aren't we? All right. So back to the flat Earth thing. Growing up, I was, and I still am, a huge Star Trek and Star Wars fan. And, whoops, did I get the wrong slide there? Okay, all right. I'm trying to go along with the slides here. But anyway, so if it was about space, I was all over it. And, like most people, I would dream about traveling the universe. Yes. That's me, Lieutenant Commander Nodell there. So, yeah, I mean, I was all about Star Trek. This particular picture was taken at the Hilton Star Trek exhibit in Las Vegas. And I couldn't wait to get there and, take a little tour of the Starship Enterprise. It was a lot of fun. So, anyway, so I absolutely have loved considering the possibilities of an endless universe. I would think, gosh, there's so much out there in space. If space ever ended, what's beyond that? I don't know. But I was always thinking about that. And now I have some different things to think about now that I kind of look at the Earth as a flat Earth. So, I spent a lot of time pouring through a lot of NASA images, looking for smoking gun proof of aliens or UFOs. And after a while, while researching NASA, I became quite aware that all of the published images that are out there are clearly fabricated. And that's kind of how I came into Flat Earth, was researching, looking at NASA. I had no idea that the answer to all the questions I was seeking would lead me to this place. But yet when I got here and realized that everything I saw was a Hollywood production, it was a pretty short leap to understand that, well, maybe the reason that NASA is hiding everything and doing all the fake underwater photos and all this stuff is maybe because they're hiding the fact that the Earth is not what they have told us. So, and I think a lot of people.
I think that's something a lot of people can identify with too, that we all didn't come into this. We all happened to fell in our lap, or was researching something else, and all of a sudden it was in your recommended. Or for me, I was looking at the moon landings, and when you find it, I don't know about you guys, but everything else made sense for the first time ever. All the other conspiracies were explained, and it's just something that when it feels right, it's got to be for a reason, right?
Mm-hmm. Absolutely. So I searched and I contemplated for nearly a year while I was looking at NASA, trying to reconcile why they would be faking everything, right? So after I came across the flat Earth topic, it was just like, wow, this is it, no doubt about it. And at that point, I started putting together a case, to try and explain to other people. And this case led to what I have often referred to in Globebusters as the preponderance of evidence. Okay, so what is a preponderance of evidence? So a preponderance of evidence is essentially a body of evidences that support a specific claim or claims, all right? It is typically comprised of exhibits and testimonies that lend credence and viability to those claims. And in the case of the flat Earth, there is not only a wealth of evidence to support the claim that the Earth is a level plane, but there's also a wealth of evidence to support the idea that challenge the current heliocentric belief. So a lot of people will say, no, you don't ever have any evidence, there's not one bit of it, and that is absolutely not the truth. In fact, the evidence is voluminous both ways. So just exactly what are some of these exhibits and testimonies? All right, well, I'm glad you asked, because we're going to cover that today. So the first thing we'll start with is some astronomical relationships. And again, like I said at the beginning, a lot of these are born trying to appeal to people's common sense, okay? So the first thing I want you to think about is consider the sun, okay? And they tell us that the sun is 865,000 miles in diameter. I mean, this is absolutely unimaginable. We have no reference to that here on Earth. We have nothing to compare that to. But even worse than that, they tell us that the sun is a whopping 93 million miles away from us. Okay, great, so they're building their model. So consider the fact that light travels at a speed of 671 million miles per hour. So if you do the math, that tells us that the sun is about 8 light minutes away from here. So traveling at the speed of light, it takes the sunlight about 8 minutes to get here. Okay, great. So, and at that distance, an amazing thing has happened. It has gone from this unimaginable, whopping 865,000 miles across, down to the size of a frisbee in our sky. It's tiny, right? So, you have to wonder, if it gets that small in just that mere small distance of 8 light minutes, what does it look like possibly from other planets, okay? So if we look at it, and we look at it from, say, Saturn, okay, so we see that even at Saturn, the sun is greatly reduced. And of course, these are honest conceptions because we know nobody's ever actually been to Saturn to photograph it, right? Then we go on to Uranus. It gets even a little bit smaller. It's beginning to look like a bright star in the sky just at Uranus, but certainly nothing like what we experience here on Earth. And then we go to Pluto, right? And the interesting thing about Pluto, other than the fact that it has Pluto on the surface of it, is that Pluto is 30 times further away from the sun than the Earth is, okay? And when you get that far away, they tell us that the sun's light at Pluto is 1,000 times dimmer than it is here on Earth, okay? So that's what, maybe the moon, maybe less, not very bright, okay? And all of this is taking place in less than 1 light hour, okay? Which is an incredibly short distance. So now I want you to consider something else that we've all seen in the sky. We've all looked up and we've all seen Polaris, and it's also known as our North Star, okay? So Polaris, as a star, is 46 times bigger than our sun, so they tell us, okay? But at a distance of 433.8 light years from us, that puts it at a distance of 27,436,619 times further away than the sun. Do you ever wonder how we can possibly see its light? Does that make any sense at all?
Trillions of miles away.
27.5 million times. That is ridiculous.
Yeah.
Million times.
Can you go find a ticket up?
So, and it's funny because when I was putting this together, I had to do the math 4 or 5 times, and I'm like, this can't be right.
And I told Bob, I said, your math is wrong here, let me do it.
So Darren did it 4 times.
That's right. So you must be 27,000 times. But no, it's
27 million times. Unbelievable. So that's obviously a really good argument that I like to spring on people, and that's what you could say to them too. You know, consider that. You know, we're dealing with 8 light minutes to an hour at most for our solar system as compared to something that's 438 light years away. It's ridiculous that they ever ask us to believe that. So another one of the common sense things that we can kind of take to our friends and argue about is when you look at the moon. There's a crater on the moon that's called Aristarchus. Okay, and Aristarchus is circled here on the map. And Aristarchus is a minuscule 25 miles in diameter. Now, 25 miles would be a pretty big object here on Earth, but when you start backing that off to a distance of over 250,000 miles, again, how is it possible that the human eye, with its minimal angular resolution, how is it possible that we could ever see that? Well, I think the answer is pretty obvious, right? It's not 250,000 miles away. So another good one.
Maybe like 300.
These are really good proofs, like I said. So another one to think about.
Detail we can see is really like.
They tell us that the ISS is about the same size as a 747, and it's also about the same size as a football field, around 100 yards, 100 meters, something like that. And we've all seen planes fly over, and we've seen them fly at cruising altitude, and typically that cruising altitude runs about somewhere between 30 and 40,000 feet, and that puts it up at about 6 miles. So when we're looking up at these aircraft and they're flying at a mere distance of 6 miles up, we are pretty much at the limit of our eye's angular resolution, all right? In other words, we can't see an object that size much further than that. Yet, we have the ISS, which is at 254 miles up, 42 times further away. Now again, apply some common sense here. How is this possible that we can see it at all, let alone as this brilliantly bright object going across the sky? Well, NASA's answer to that would be definitely, well, it's because the sun, when it's below the horizon, it's shining off the bottom of it and reflecting it. Of course, the ISS is not exactly a reflective object, and if you've ever watched the ISS live feed, you know that it just doesn't light up like that. So again, another big disconnect. So there's a NASA app, and it is called Spot the Station. A lot of you may be familiar with it. Does anybody use it? Show of hands that uses the Spot the Station app? Okay, well, a few of you. Well, if not, you can Google it. And what Spot the Station does is it will notify you whenever the ISS is going to fly over your town, all right? And it's kind of cool because it tells you exactly when it's going to be there, where it's going to rise, what part of the sky, and it tells you how long it's going to be visible before it disappears over the horizon. Okay?
And it's free.
And it's free. Good part, right? So, I did this.
Free indoctrination, she said.
Right. Right.
They're not going to charge you for that, just like school. I always wonder, why is school free? Oh, no.
Yeah, it's amazing. So anyway, many of these apps are free, and that's great. So whenever it will fly over, and any of you that follow Globebusters will know that we did a Tuesday night show, I believe, on the ISS for well over a year, where all we did was sit there and watch the ISS, and we ran across some doozies. Oh man, NASA was bad. So, but after a year, we gave that up, and I started, after I got my P900, I'm like, okay, I'm going to go out there and I'm going to see if I can get a picture of it. So I would go outside early in the morning, because it usually will appear just before sunrise or just after sunset, and I would get up and go out in the morning or in the evening. And in Denver, we have over 300 days a year that are absolute sunshine. Beautiful weather there. And so I would go outside and I'd look up, and sure enough, I'd see the ISS coming over the horizon. Well, when I went outside, I would bring up both live feeds. Now, the ISS, you may not know this, the ISS has 2 live feeds on Ustream. One is an HD feed and one is a standard resolution feed, okay? So I would bring up both of those feeds, and I'd go outside and I'd see, the clear sky all around. And here comes the ISS, kind of lumbering along. And then I would look at the live feed. And then I look at the sky. And I look at the live feed. And it's like, wait a minute. The live feed is showing not only Denver is completely overcast, but the entire country and most of the world, right? So, and this is something that happened time after time after time. Again, Jaren's done it. We've asked our viewers to do it, and this is something that you can do, right? If you want, we all get the argument from people. Oh, you can see the ISS flying overhead. It's got to be there, right? Well, there's something there, but I don't think it's the ISS.
And it's something that you guys can do yourself, since it's all free, and there's even, I think it's called screen capture. I can't think of the name of the site right now, but there's a free screen capture site. Screen Capture-matic, something like that? I don't know. But you can...
Screencast-o-matic?
Yeah, Screencast-o-matic. And you can bring up the live feeds and start recording that, and then go out in front and film the ISS as it goes over your head. And then go back in and look at the recording, and you'll see what I saw. I have a couple of different videos my channel that show we had a completely clear sky, and we watched the ISS go over, and we ran inside, and sure enough, the entire sky was covered with clouds. So when these people tell you that it's proof, or the ISS is proof, ask them to do the same thing. Ask them to get video footage from the ground showing it. Because most times, isn't it convenient that the ISS, when it flies by during the day, it can see the ground, but during the day from the ground, you can't see it. But at night, you can see the ISS going over, but from their view, you can't see the ground. They just show black. So awfully convenient and an easy way to fool you, rather than what I think would be proof is if you had a 24-hour camera on the ISS, and just to think about that is enough to drive anybody crazy. How can we not have a 24-hour camera of the Earth, a 24-camera view of where we live? It's our money that NASA exists off of, and I always get upset that the first thing they should do is take care of those who are funding it. And then if they want to go play in La La Land out in Saturn or something like that, that's fine. But they don't even start by satisfying us with a picture of our home. 24-hour view, they say, oh, it's going on the dark side. You've seen me make fun of the blue screen that comes up because they say it's on the dark side of the Earth. Yet they supposedly have satellites. It doesn't make any sense. You can't have both. If you have a satellite, then bounce the beam off and back down to Houston, but they can't do it.
So, needless to say, it just doesn't make a lot of sense. And, we do say that a lot, and that's because these things do not make sense, and they are non secular, they don't follow. They don't follow common sense, they don't follow logic. But because of the fact that NASA says so, and science says so, we're kind of forced to take them at their word. But we're not going to do that. We're not going to do that. So, now I want you to think about, picture in your head the following, okay? So they tell us the ISS is traveling at a speed of about 17,500 miles an hour, give or take, okay? Now, the speed of a bullet
goes faster than a bullet.
Is about half mile per second, right? About 2,500 miles per, or 2,500 foot per second, excuse me. So about a half mile per second, and if you work out the math, it works out to be about 1,700 miles per hour, plus or minus, okay? So what does that tell us? That tells us that the ISS, at the size of a football field, is traveling over 10 times the speed of a bullet.
Crazy.
Is that reasonable? Crazy. No, I don't think so. Of course, NASA will say, well, there's no atmosphere up there, nothing's going to tear it apart.
We believe that.
So, of course, we can go
Why did we believe
absolutely. That? So, okay, we'll accept that. So, we have something to compare it to, though, and this is one thing that I think a lot of people don't really think about. I want you to think about if you've ever seen meteor showers, like the Perseids or the Leonids. You go outside and they come in, on a yearly basis, and they're always there, and they're quite beautiful, and they're quite spectacular, and they're quite noisy if you get in a spot where you can listen to them. They have a very crackly electrical sound. But the thing that I want to highlight about them is when we look up some information on meteor showers, we find that they streak across the sky at anywhere from a speed of 25,000 miles per hour to, and that's for the much smaller, or the much bigger ones, excuse me, 25,000 miles an hour. And that would be up to 100 yards or 300 feet. After 300 feet, NASA reclassifies meteors as asteroids, and we certainly don't want to see those, right? So 25,000 miles an hour for the large ones, and the micrometeorites travel at a speed of about 160,000 miles per hour. Okay, so if we kind of average that out and say that your average meteorite is going to be traveling at somewhere in the speed of maybe to 70 to 90,000 miles an hour. Okay, we're talking about a factor of at minimum to maximum of 8 times slower, and that's kind of taking it to the extremes. But more on the average of about 5 times difference in speed. So when we see these meteorites go across the sky, I mean, they literally just go whoosh, and they cover a great swath of the sky instantaneously, within a fraction of a second. And they're only doing maybe 3 to 4 times the speed of the ISS. So when we go outside and we watch the ISS and you see it come over, and it's doing its 17,500 miles per hour, it just kind of lumbers across the sky, and it takes anywhere from 4 minutes to about 8 minutes to completely traverse the sky. Now there's another really big disconnect there, right? In comparison to meteorites, it just doesn't add up. And this is, this is another one of those great big disconnects. It doesn't follow, non sequitur, as I like to say.
17,500 miles per hour, that's about 90 football fields in a second. So when you picture yourself being in a football game or looking at a football field, to think 90 in 1 second is ridiculous.
Yeah, it is. It's absurd. We have a hard time even imagining the speed of a bullet, let alone something going 10 times that size. It's a little crazy. So, and granted, I will make the concession that yes, the meteors are coming in and burning up in our atmosphere at about 1/3 the altitude of the ISS. But still, even if you compensate for that, shouldn't we really be seeing the ISS traverse the sky, all the way across the sky, in a time of about 7 to 21 seconds, rather than 8 minutes?
And that's another thing, to see these meteoroids coming in, you have to look down from the ISS, meaning they could be hit at any time. And yet it never happens. They're just happy to say that you can look down at the atmosphere and watch them light up. It's crazy.
Yeah, absolutely. And if you've ever watched the Perseids or the Leonids or anything like that, you know that they come in at a fantastic rate. And these are just the ones that they tell us about that are so spectacularly visible, right? They tell us that we get hit by absolutely millions and millions and millions of meteors every single year. In other words, we're constantly being bombarded with it. Okay, so think about this. If that's actually happening, and these meteors are coming in at a speed from 25,000 to 160,000 miles an hour, all of them are coming through where all of the geostationary satellites are at roughly about 25,000 miles up, all the way down to where the low Earth orbit vehicles are, like the ISS. And if anything going at that speed would hit any spacecraft or the ISS or, God forbid, any astronaut out on the spacewalk, they would be annihilated. They would absolutely explode at that velocity. Nothing could withstand that. I don't care how much Kevlar or anything that they make these out of, nothing is going to withstand these little bits of iron that are flying into the atmosphere at that speed. So that's just another thing that you've got to consider. Why is it that we never see these catastrophic collisions that are hitting our communication satellites or all the other, whatever the figure is? I've heard a figure of anywhere from 4 to 40,000 satellites in space. I don't know what it is because it changes from every site that you go to. But yet, the ISS is never damaged. Well, I take that back. One time, I think, this is so funny, they made a big deal. They said, well, a meteor strike actually struck the ISS, and this was about 5 years ago, I think, something like that. And it was funny because I was a big reader of this website called Clues Forum. And Clues Forum did a picture expose on it. And it was so funny because all the space agencies that were involved in it, like the ESA, NASA, JAXA, whoever, they all had different pictures of the damage that was supposedly done to the ISS. But what was funny is not only was the damage different, but the entire solar arrays on the ISS were completely portrayed differently, and they were submitted. So the space agencies couldn't even get their act straight on that. It's absolutely amazing. So again, these are common sense things. Why don't they ever get hit? Why doesn't this happen? Why aren't we constantly losing communications? Why don't we lose our DirecTV or our Dish network? It just doesn't ever happen. So that's another thing. So let's talk about some of the problems in the heliocentric model and kind of move on from that. So one of the biggest problems I think in the heliocentric models, first of all, is the seasons. Okay, the heliocentric model, as well as the polar climates, appear to be completely non sequitur. There's that word again. With the explanations that are given for them, okay? For example, in the heliocentric model, the sun is 3 million miles further away, or that equates to 379 Earth diameters, further away in the summertime, the northern summertime, than it is in the winter. Well, NASA tries to explain that away by the tilt and all that stuff, but again, these explanations really don't wash, because when you look at the climates and the ecosystems in the extreme north latitudes, where it's like 60 degrees north, where we we see that Norway has got a beautiful, lush ecosphere. It gets colder, yes, but it actually gets to be nice days, lots of vegetation, there's lots of indigenous wildlife, all kind, night and day. And then you go and you look at the South Pole, McMurdo. Well, you go down there and basically the only indigenous life form is the emperor penguin, and it's essentially a desolate wasteland. And this is the way it goes from 60 south all the way to 90 south, allegedly, right? Complete disconnect, once again, from its opposite complementary latitudes. So, and then when you look at the latitudes between the equator to 60 south and the equator to 60 north, every complementary latitude is virtually identical in climate. So that drives, but as soon as you get to the polar regions, there's an absolute and total disconnect that makes absolutely no sense whatsoever.
And this one's completely opposite. It's so wrong, it's not even funny. To have the cold end be where the sun is closest by, like Bob said, 379 Earth diameters closer. Anybody can go outside during the summer and you know that the sun is closer to you in the summer. You can feel it, it's right on your face. Go out at noon on a summer day and look up at the sun, and then go out at noon on a winter day and look up at the sun, you won't even feel it. And then to try and believe that it's 3 million miles closer to you simply isn't the case.
Yep, absolutely true. So, another thing for you to put in your arsenal when you're talking to your globy friends, all right? So, eclipses. Well, eclipses, this is something that's amazing. We recently went out to Alliance, Nebraska and witnessed the eclipse, and if you've never seen anything like that in totality, it is absolutely one of the most beautiful sights you will ever see in your life. Interestingly enough, though, we never saw the moon come in. We just saw this black, dark object. We never saw any hint whatsoever of the moon. A lot of people argue that it is there, but we couldn't see it, let's put it that way. But beyond that, there is a body of evidence, a rather large body of evidence, that indicates and tells us that the eclipses as portrayed in the heliocentric model really don't work. And we have studied this ad nauseum, and there's a group of researchers that's very dedicated to this, and in fact, they have gone so far as to put their money where their mouth is, and they issued on Facebook what's called the $5,000 NASA Eclipse Challenge. Now, this wasn't just something that they posted on a Facebook page, hoping that people would be able to see it and take up the challenge. What this guy actually did is he actually physically mailed, snail mail, hundreds of universities all over this country and all over the world to their astronomics departments, astrophysics, etc., issuing this challenge and saying, look, if you can match this data up with the heliocentric model, you got yourself $5,000, right? You would think that somebody would take that offer up, but to this day, nobody has ever taken that offer up. And if and when they do, I'm sure it will be big news. But and this challenge has been out there for what, 2 years?
Yeah.
Something like that. It's absolutely out there. So we're willing to put our money where our mouth is, and actually issue some of these challenges, but it's amazing. It's just crickets. So we've all seen a lot of the NASA stuff, and actually I was going to cover a whole bunch of NASA stuff, but when Rob Skiba came out here yesterday, and you can hear him with a lot of his stuff, they really kind of covered a lot of the stuff that I was going to cover, and I don't want to duplicate it. So that saved us a little bit of time, but
if you just allow me,
sure.
Can you back to that slide? Because a lot of scientists talk about that the only shape that can produce a round shadow on the surface of the moon is a spherical shape, So first of all, a cylindrical shape is also can produce that round shadow. But this footage was sent me by a friend from Italy. It just, like a joke footage. Can you put it play? You're gonna see that he compared with the shadow of the eclipse of the moon, of course. He had his notebook, and just for fun, he's gonna take a rectangular shape. So you're gonna start to see how the shadow projects on the spherical object, and you're gonna see that if the object is a sphere or hemisphere, you're going to reproduce the same kind of shadow. So maybe the Earth is square, no?
Right. So how many times have we heard this argument, right? Okay. It's like the old deGrasse Tyson, oh look, it's... Yep, that's great. Oh look, the only thing, this proves that it's the Earth eclipsing because the only thing that could possibly cast a shadow like that is a spherical object.
Yeah, remember that any light you see on the sky is projected in the last layer of the atmosphere called the Kalman light. So maybe the moon is spherical, maybe the moon is hemispherical. We don't really know, but when you see from the ground and you look up, you're gonna see all that light compressed in the layer of the atmosphere. So that is why it's very difficult to imagine if the volume of that sphere. So maybe the moon is spherical. We don't know.
Absolutely. So that's another good one. Good job, everyone. All right. So we've all seen these pictures, the famous blue marble, the fact that they're created in Photoshop, but it has to be, right? We see the cloud stamping. We see they put the word sex in the clouds. It's just ridiculous. On one picture, they have the United States that literally takes up half the globe. It's absolutely ridiculous, the inconsistencies that they come up with. And these are very easy proofs. And these are supposed to be legitimate images. But remember, as Zero pointed out yesterday, the word images comes from imagination, okay? So that's exactly what they're doing, is they imagine these, they drip this up, and that's about it. So, Ira, do we have some other things that we wanted to roll on the NASA?
Yeah.
Do I have that?
I really gave some of the footage that yesterday I can maybe complete, show you. If you can.
Or what's that? Is that the video? I'm not sure.
Yeah, there is a couple of videos. The first one is, of course, that this has a little audio talking about how it was made. So if you can play.
The shot is compiled from data from NASA's VEERS instrument, which orbits the Earth about every 100 minutes, taking measurements of light coming off the planet. That can be translated into ribbons of imagery like this.
There's a small problem with it because there's a very slight gap in between each orbit.
So some of those are painted on.
It is Photoshop, but it's has to be. It is Photoshop, but it's has to be. It is Photoshop, but it's.
What is noticed is that these guys make all about CGI. For example, this is a software that ESA uses to all that picture taken from the ground, and they compose it on the Photoshop. They have their own apps running inside Photoshop, and so that is how they mix the lights and present us like a real galaxy taken from the Hubble. So it's all made on computer. They are already done. That was the supposedly telescope up in the space, but then you realize that all that kind of image I'm taking from a plane or Sophia, I think everybody knows already, but that is how they fake planets, they fake galaxies. They are not just faking everything, because the main picture or the main image is taken real, but it's from the ground. It's not outside telescope in the space floating there, and the telescope have the only capabilities to take that photo because it's without any kind of atmosphere layer distortion or blocking the view. It's taken from a plane. If you go just 10 kilometers, 50 kilometers up there, you're gonna see really clear sky, and you're gonna take a lot of pictures in infrared and that kind of technology. So that is why they fake it. If you come next slide. For example, I show you yesterday a little bit of this. Anyone nowadays can put in Google Earth map texture, and you're gonna find all the texture you need about the cloud.
Yeah, he made that.
Layer,
he made that
ground
video.
Layer, the city lights layer. It's already done there, and you can also lots of quality image. This is me playing, with little 3D models, putting in After Effects, changing the shadows, and when you see that kind of image, you must understand that they can film from drones, from balloons, or plane. They just pass over, filming the real surface, and then mapping on the sphere, they composite, and then you have the ESS like show. That is how it's very easy on those days. And the next one, please. And for example, like I showed yesterday, they have been doing this for a lot of years, and the masters, you know, with the years, really become a master. So that is why it's so shitty image they are downstairs. And of course, they have the most technology painting board ever made, which is this one. They do it only in the. This is a picture from the 80s, because in the 80s the CGI technology, you know, it was better painting than doing a computer. So right now they start making a computer, but if you take the line time, you can see how they get better and better and better until those days. Of course, you have all the patent there. If you can go slides, next slide, because it's just for showing that you have all this for your own if you want to research. Can you next?
And I've had people ask me about, or tell me they have an explanation for that track and the moon ball, the half hemisphere there. And their explanation is that, oh, they use that for practice. So I've asked them, well, where's that footage? Let me see the footage of these practice rounds they did with this camera on a track that's out in front. And of course they can't supply that because it would look exactly like moon landing footage, which is what they actually used it for. They would have both. They would have an example of, well, this is our practice and this is when we actually landed. But there is only one set of footages, and that's the one that they used to tell people that we actually landed. So obviously that was used to fake the landing.
Yeah. Is that it? That's your part?
Okay. All right, beautiful. We kind of hurriedly put this together yesterday because Iru was kind of a last-minute addition. He did such a fantastic job yesterday that we really wanted to make it possible for him to present the rest of his materials. So excuse those little transgressions there. Okay. So next up, ISS and radiant heat. Okay. So the ISS orbits in what they call the thermosphere. Okay. And the thermosphere is a region of the atmosphere that gets as hot as 4,500 degrees Fahrenheit. Well, at that temperature, there are very few metals or very few substances on Earth that will withstand that kind of heat without turning into, you know, molten, just whatever. So NASA says, well, the reason that the ISS just doesn't, you know, completely melt up there, and this is kind of a misdirection, by the way. They say, well, at that level, the air molecules are so sparse that any type of convective heat to the ISS would be non-existent because these little, you know, so few air molecules are never going to pass that heat on. Well, that's all fine and dandy, except that's not the issue. The issue is not a matter of how the ISS is affected by convective heat, but it is how it is affected by radiant heat. And this is the type of heat that is hitting it directly, right? Okay, and not only would the radiant heat from the sun, supposedly, like I said, if they knew this was real, which we don't believe it is, not only would it absolutely fry anybody inside, it would melt the ISS. There's no way they could possibly, you know, convect this heat away from the ISS. They just simply can't do it. So, but in addition to that, you know, so you have to go back to thinking, what exactly is it that's heating up those sparse air molecules to 4,500 degrees? You know, again, it's that radiant heat. And along with that radiant heat comes gamma rays and X-rays, which are very lethal to human tissue. Not much can withstand that. And honestly, it would probably take a couple feet of lead to be able to shield anybody from that type of radiation. I mean, think about it. When you go to a dentist's office, they put a lead apron on you just for shooting a little dental X-ray. These gamma and X-ray radiations are orders of magnitude higher, and nobody could really survive it. And NASA just conveniently really doesn't address that, but they do talk a lot about how the Orion project is going to be trying out all this new shielding, right? So they obviously are acknowledging it. But anyway, so when you're dealing with radiant heat, and you are looking at what the ISS is made of, carbon, titanium, aluminum, composites, stuff like that, really what it is ideal for is to create an oven, right? So that's exactly what's going on. The crew would be cooked. It's simply not possible to do this. They have no reasonable explanation for how the ISS can be flying around up there, let alone anybody surviving on it. And then there's questions about the electronics. It just goes on and on and on and on. But we'll kind of leave it at that. So we'll move on. And one other thing I want to point out, and many of you have seen this photograph. This is the crew of the Challenger, and we all saw STS-51 go up in flames. And it appears today that most of these, if not all of these astronauts, and likely all of them, because if one survived, they all did, are likely alive. The only picture that we kind of disagree with on here, and Jaron brought this up to me yesterday, is Judith Resnick. She's the one in the lower right-hand corner, and she's the Yale law professor. We found some earlier footage, or Jaron did, found some earlier footage of her, and the earlier footage of her looks much more like her older self than the Judith Resnick that went up on the ISS. So that's possibly not accurate. And we just kind of want to acknowledge that. But the rest of them, Dick Scobie, which to me sounds like kind of a venereal disease, it is absolutely it's absolutely the same guy. And as far as the other ones, two of them allegedly have perfect twin brothers. Of course, again, in researching birth records, there is no birth record of twins with these astronauts. So again, it's another fish story with NASA. Okay? So, all right. So then, we move on, and a lot of us have looked at the Apollo missions, right? And I'm not going to say a whole lot about this because Rob did a great job. Allus.com is a fabulous website for researching this, but as one of the people in the community defines this looks more like a homeless tweaker shelter than a lunar lander. And when you look at it and you scrutinize it, the construction of it is absolutely ridiculous. It looks like it was put together with Scotch tape, aluminum foil, a little bit of construction paper, maybe some gray paint. And also notice that there's no blast crater or anything like that below it. I mean, absolutely fabricated, set on the stage. And for anybody to believe that this thing withstood the velocities and the heat and the radiation and all the stuff that it was supposed to do, and they did this back in 1969, no way, Jose.
And then it took off and reconnected with the command module in space.
Yeah.
No coordinate system to reference.
It's on YouTube.
It's just
But I'm I'm Chris Holt. I'm Smiley Chris on. Yeah, Smiley Chris is the YouTube.
All right. So enough harshing on Apollo. They're too easy. That's just too easy of a target. Okay, so next up, we're going to talk about some of this guy's work right here. All right. If you don't know who this is Nikola Tesla. And many people have never heard of Nikola Tesla, but I would say that Nikola is probably arguably one of the most brilliant men to ever walk the face of the earth. Yeah, absolutely.
Never mentioned his name.
Never. No formal education. So anyway, where I get this, I got to tell you this. I got this statue from Iro. Iro brought this to me from Argentina. A good friend of his made it, and they made it specifically for my birthday. My birthday was November 6th. I just turned 57, and he wanted to. So Iro wanted to bring something that would be very memorable, and when he brought me this, I was just blown away because I love Nikola Tesla, and I will absolutely cherish this. Thank you so much for it, Nikola. So, in the spirit of Nikola Tesla's work, we, both Iro and I, are big fans and proponents of what's called the electric universe model. And the electric universe model is primarily, it's called the Thunderbolts Project, if you want to look it up on the web or on YouTube. And it is made up of a large group of scientists and engineers, a very large group, and it's growing exponentially. I mean, it's unbelievable. They also have the EU conference every single year, and it's a conference that's probably rivaling the size of this one. And it's very, very much catching on with all the physicists and engineers. So all of these scientists and engineers pretty much all believe that the gravitationally ruled cosmology of our universe is nonsense, right? They're not on board with Einstein, not a bit. They see the universe as an electrical phenomenon. And being an electrical engineer myself, that is exactly how I view the universe as well. It makes perfect sense, every part of it. And the evidence is absolutely overwhelming, but we'll cover that a little bit. So they realize that, you know, gravity is nonsense, and of course, they are up and coming, they're very much emerging. So recently, after only a mere 4 billion year wait, gravity waves, as you may know, have finally been discovered, right? And it isn't as if we weren't already swimming in multiple gravitational waves, right? The moon, the sun, all these other gravitational influences that we can have. No, it took an event that happened a long time ago in a galaxy far, far away to bring us the detection of gravity waves from LIGO, all right? Billions of years ago, and like I said, in a galaxy far, far away. And they needed to do this to prove Einstein and his gravitational theory is correct, because basically they are really taking a beating. In fact, general relativity in general is taking a beating. It just doesn't make sense, and a lot of physicists today know it. So it's not just us crazy flat earthers that know this. It's a growing number of scientists and engineers. So
And it just so happens that they did that on the 100th anniversary. It was 100 years to the year that Einstein had predicted gravitational waves. Surprise, they got it.
Yeah. So the electric universe model is demonstrating reproducible phenomena in the lab that mimics and explains the phenomena astronomers are seeing in what they believe to be deep space, okay? We as flat earthers support this work because not only do we believe that they are probably onto something, but when scaled back and modeled inside of a closed system Earth, as we believe it is, it works perfectly for the emerging electromagnetic, electrostatic flat Earth model, okay? And more information can be found on this by searching, like I said, the Thunderbolts Project. So some of the highlights of the EU model is that it defines gravity as an electrostatic force. And this is something that I've done on Globebusters and demonstrated this. Works very well. The Earth has a naturally occurring electrostatic field that runs on the average of 100 volts per meter growing up. This is absolute mainstream science too, by the way, that I'm quoting. It extends to at least 50 kilometers, and this means that the static potential between Earth ground and 50 kilometers up is 5 million volts. And so it's not hard to understand where lightning and sprites and things like that, electrical phenomena in the sky come from, because it's natural, it's part of this biosphere. All right, so the other thing that the EU model defines what it does is it predicts and it reproduces and explains virtually all observed phenomena in the universe. It describes the universe as plasma-based, electrical manifestation. It predicts the sun as an electrical plasma device and a counter-spatial energy converter. And a lot of you may have heard of Professor Eric Dollard, amongst many other people that are absolutely on board with this and have done a lot of fantastic work under college grants. So it's a very real thing. So it is very similar to the emerging electromagnetic, electrostatic flat Earth model. The difference, again, is scale. They're scaling electrical phenomena up to a universal level, and we're kind of keeping it in our little terrarium here. But either way, it actually works because all electrical phenomena is scalable, especially when you're dealing with plasma physics. So physicist Walt Thornhill, the lead scientist of the Thunderbolts Project, gives a terrific explanation, okay? So I'm gonna let Iru do some of your slides. I think you're going to put those in. I'm just going to talk about these.
I showed you this yesterday, but not the complete one. First of all, if you see here, you have a smaller scale that reproduce how the terraform geological phenomena can be made by electrical force. That is the symbolic of Zeus, you know, the thunder creating the world. And you can see it's exactly the same shapes, the same, that kind of energy level that can shape our planet, our brain. And these guys are reproduced on that, so you have a science involved there. And for example, here is something that not much people may aware, which is called globular lightings. These are electrical fields discharge of the atmosphere. They are not rocks that enter the atmosphere. Look at the trails that this is going to form there. That shape is only made by electrical forces. Whoa. So then the mainstream media show this kind of stuff and say, and meteorite entered to Russia. It doesn't have any sense at all, because it's all that kind of stuff. You can explain it. The next slide, please. You can explain by electrical universe. Bob recently talked about the sprites, for example, and the word sprite means spirit. So that is why they talk about angel in the skies, because they are non-physical guys, with wings flying there. These are the angel, the sprites, that kind of symbolic names. You can see here all these churches. You can see here the shape of the angel, if you want to see it in that way. So when you start to look in all that kind of things, you notice that here you can see the perfect combination for anode and cathode. You can see the aurora borealis, which is one of the most powerful energy in our plane. That is, if you want to see the ether, you have that directly. That is why all the elite uses in this model of symbolic knowledge. The next slide is about. I really like to enjoy this short clip from Don Scott, because he can explain how the sun's the electrical model of the sun works, but he can explain all the difficulties that the heliocentric sun model have. It's just 2 minutes, so enjoy.
Good afternoon. My name is Don Scott. The electric sun is a sort of a natural outgrowth of the electrical universe hypothesis. We know that there are magnetic fields.
And that part is not soundless. Sorry, it's going to come the sound. This is the model of this guy presented as sun as a machine. Not just, a fireball up in the space.
There seems to be a new model, or at least another patch on the previous existing model. Problems that I feel, at least, are fatal, absolutely fatal, for the models that are so-called accepted these days. And I would like to then demonstrate how precisely those problems